Hi everyone, today I will be covering performance testing. And the things that I'll be covering is why performance is important, some example scenarios, how to run performance tests, core metrics and what they mean, and then finally wrapping up with tips to take away. So firstly, my name is Claire. I am an engineering manager at Safety Culture, looking over a couple of engineering teams, as well as a front-end performance initiative here. In my free time, I am involved with Women Who Code in Sydney, as well as a resource hub called Women TechCast. So diving in, why is performance important? In my experience, I've worked in environments where systems have high load with millions of users that visit. And in these environments, the reliability of systems are important. Slow or unresponsive sites can negatively impact user experience, break trust, and have business impacts. So let me take you back to 2009, where users could see this image, which is called the fail whale, every time Twitter experienced outages as they were growing their user base. Now, fast forwarding to a recent example, Signal recently experienced some scaling problems as users were switching over to their platform. And you can see here, they're very excited about having more users, but at the same time, they knew that they had some performance challenges to overcome. So now we talked about the reliability of systems and why that's important. Let's look at what performance means in the front end and the associated user experience. So with more and more users using mobile devices, the response times of pages are becoming more important. A study conducted back in 2016 by Google found that 53% of visits are likely to be abandoned if pages take longer than 3 seconds to load. And 1 out of 2 people expected a page to load in less than 2 seconds. Other interesting things they found was that the average load times of mobile sites take 19 seconds over 3G connections, which is a very long time. And then mobile sites that load in 5 seconds earn 2 times more in mobile ad revenue than those that loaded in 19 seconds. The last thing that they found was that 46% of people say that waiting for pages to load was what they disliked the most when browsing the web on mobile devices. Taking a real life example, in 2015, Pinterest ran an experiment on their mobile homepage. What they did was they improved the landing page performance by 60%. And as a part of that, the mobile sign-up conversion rate also improved by 40%. So from these learnings, the team at Pinterest worked on productionizing from this experiment and refactored and rewrote a lot of their pages to improve the performance. And what they saw that this led to the biggest increase in user acquisition in 2016. So what I'm showing you now is a film strip that corresponds to a performance test run on a site. And I've just picked any site here, so there's no bias or anything. But you can also see in this example, the page was fully loaded after 13 seconds. And it really makes you think, how long do other pages take to load? So for the rest of this talk, I'm going to focus on the front-end performance, covering the user experience as pages load. I will walk you through how you run performance tests, understanding core metrics, and some tips on what you can do. So there are many tools to choose from, and I've listed a few here that are commonly used. Some are already free and you can jump on and use them. For example, web page tests and Lighthouse are free, but you can also have a look at other things that are used widely in the community. The other thing here is Lighthouse comes with your browser, so you can get up and running quite quickly. For this talk and the examples that I'll show you, I'll be using Lighthouse because you can get up and started quite easily. So like I mentioned, Lighthouse is available in the browser. It is under the network tab, and you can navigate to the Lighthouse tab and then generate a report against a page that you're interested in. Because it is in your browser, it's also quite easy to debug things locally and investigate. It's very popular in the community. There's lots of documentation. And then you can also extend this to integrate with your CI/CD pipeline, for example, using their library or their API. Lastly, Lighthouse generates a useful report for you. So you can see, for example, the performance scores and recommendations that you can take to improve the performance of that page. So to get started, this is a Lighthouse library that we'll be using in the examples. You will need Node and Yarn to use this library. The first thing that we're going to do is use Lighthouse against the command line. So the first thing you want to do is you want to install Lighthouse. And then this is an example of how you'd run a test against a page. So you can see this is starting with the Lighthouse command, targeting a URL, and then some options that we're passing in. The ones that I've chosen here will be running the test in headless mode, and you may want to use this when you're running this on your CI pipeline, for example, and then spitting out output files for the results in JSON and HTML format. There's also a lot of other options that you can use, so I encourage you to check it out and try it out. And you can see, for example, you can change the user agent, you can define budgets, and then you could throttle some of the tests. And that's useful, for example, if you want to see what the test would run under a slower connection. So now let's see this in action. So this is me running the test on the command line. In this case, I'm not using headless mode, so you can see what's happening. And you can see when the test is running, the page loaded against the page that I've defined, and then a test will be generated. After that, you'll get some of the results. So you can see here, this is a nice HTML result of what the performance was like for that test. A few key things to point out here is you'll get the performance scores for that test run, as well as some core metrics. So looking at things like largest contentful paint and how long that took, and a bunch of other metrics. We'll cover that later on in the talk, as well as opportunities. So things that we can do to improve the performance for that page. Another way to use the library is writing custom code. And in this example, I will be choosing how to test against authenticated pages. So in the previous examples, we've seen how we can test pages that are publicly available, but there are some cases where pages are behind an authenticated route. So I'll show you how to do that. The first thing that we want to do is log in. So what we'll need to do is figure out how do we do that in the test. So for this case, we're going to use Puppeteer and Lighthouse together to do that. And we'll need to then add in the required libraries and now define the login function. So the first thing we want to do is we want to navigate to that login page and open that page, followed by finding the email field and populating that field, similarly with the password field, and then lastly, submitting the page. Now that we've got the login function, we're ready to run the test. So again, defining a function, we will open the browser using Puppeteer, and you notice that you can add other options, for example, headless mode. And then we're ready to log in. After we've logged in, we want to run the test, the Lighthouse test, against the page that we are targeting. So you can see it's quite similar. We're calling Lighthouse with the URL and passing in some options. And then lastly, after we've run the tests, we want to save those results into output files. So in this case, we've chosen how would you save the HTML as well as the JSON results. So here's the example test run of a page that's behind an authenticated route. So we're calling a example file. So we just save that code in something called auth.js, for example. And then we're navigating to a login screen and adding in the email field, followed by the password field, and then submitting. So now that we're logged in, we want to navigate to the page that we want to test. So after we've run the test, we might want to do other things. For example, we might want to now automate this so that it's a part of our CI/CD pipeline. So every time we have code that's merged in, for example, we might want to run a performance test. This is a real example of how we can do this. So in this case, we have a pipeline defined in BuildKite, and the tests are run after each merge. And you can see as well that it's run against a particular region, which we can define, and against a particular device connection. In this case, it's like mobile 3G. Other things that you want to do is you might want to monitor how is the performance over time. So in this case, what we've done is we've parsed the test results and then saved this to a database to be displayed on a dashboard. And this is useful if you want to see the trend of the performance for particular routes, and as well as identifying areas that need improvement and then diving into those test results to understand how to improve it. Okay, so we've covered how do you run tests, and I've alluded to some of the test results. So now we want to dive into understanding those test results. And we will start with the core vitals to understand what they mean before diving into some improvements we can make. So over the years, there have been many different performance metrics. And as of 2020, there was a cleanup. And out of that, there were 3 recommended core vitals that most people will start with. We will cover what they mean and then some ways to improve these metrics. So let's take a look at largest contentful paint. This is when the largest content is displayed on the screen, and that can be anything from text, images, video, and other types of content. And you can see example I've circled or highlighted what that looks like on a particular page. So this metric is important because it's related to perceived load speed and tells the user that something's happening, something's loaded on the page. The next thing we want to look at is cumulative layout shift. And what this means is basically figuring out the ratio of when the page shifts. So you can see in this example, we've highlighted 2 particular regions. One is the distance, so how far down did the content shift down, as well as the impact. So where did the content end up shifting down to? In this example, you can see that the distance that the content shifted down was about 1/4 down the page, and then the impact, the content ended up 3/4 down the page. So this is important because this can highlight a poor user experience if the page shifts down significantly. So for example, imagine if you're reading an article and then when an ad loads, the content shifts down and you may end up losing your place. Or another bad example could be if you are about to click on a button, the page content shifts down and then you end up clicking on something else. It's not a really great experience. Finally, we'll cover first input delay. So really what this means is how long will the browser respond after a user interacts with that page. So for example, if a user is clicking on a button, how long is that wait before the browser responds to that action? And this is what we call the delay in event processing. This is important because it's the user's first impression of how responsive is the site. If a page takes a long time to respond to the user action, users could lose interest and abandon the page. And the reason why there could be a delay could be because the browser is busy executing JavaScript or loading other resources, for example, loading a large JavaScript file. So now this diagram will demonstrate what happens in the browser when the page starts loading. So the gray bars on the top are the network requests to fetch resources. So think about images, videos, text, other JavaScript files, CSS files. Those would be termed as resources. And then on the bottom, gold bars, that's the main thread. So what's happening in the browser as those resources are loaded in and as it's executing different JavaScript files. And then at some point here, we've marked when the browser starts loading styles and starting to paint some of that content. So adding an image, for example. And then at some point later, a user will interact with that page. So for example, clicking a button. And after some execution time, the browser will then respond to that action. And so that's what we call the first input delay. Now, there are many other metrics that are included in performance metrics, but I'll highlight a couple here so you can understand what they mean and how they play into the performance. So taking a look at this film strip, this was the performance test of the video that we saw earlier at the beginning. And I've also included the test results from that run, which include other metrics, in particular, time to first byte, first contentful paint, and speed index. So starting with time to first byte, this is actually when the server responds to the first byte of content. And this could be text, for instance, as the first byte. Then we'll have first contentful paint. So that's actually when the user starts seeing something being rendered. And then largest contentful paint, which we've covered already. And that's actually when the largest content is displayed and visible to the user. For speed index, this is the average time that most parts of the page are displayed to the user. And then finally, with cumulative layout shift, the ratio of when the content has been shifted down. So now that we've covered why performance is important, some real life case studies, how to run tests and integrate this into your pipeline, as well as performance metrics, let's dive into how can we improve performance. The first thing that I want to touch on is what is the critical rendering path and why we will use this for assessing how to improve performance. So firstly, what is it? It's actually identifying the critical items that need to be rendered on the page. And this is usually what is termed above the fold content. Basically, that means content that's visible to the user and not off the screen. So if you can think of your mobile device, what are all the elements on the screen that you need to see, and everything below the fold or below what you can see is not included. And then we need to understand, how do we identify what's critical, and then how to formulate what to break up. So some of the things that we'll need to do is understanding the number of resources that are critical. And then how long does it take to load those resources and their dependencies? So if you think of a CSS file, that can refer to images, other font styles, for example. And so that means that is now a dependency of that CSS file. And then finally, the size of critical resources. So for example, if we're loading in a really high resolution file or image to a small device, that may not necessarily be efficient. So we may want to look at that. So this is, I guess, a film strip of when elements and content is displayed to the user over time. And then how this works with the critical render path is basically what happens in the browser to start painting that content onto the page. So we'll first start with parsing the HTML and the styles to form something called a CSS object model. Then using that, we'll have a render tree, which consists of all the elements that need to be visible to the user. So if it's text, that will be included in the render tree. If it's a style associated to that text, it will be included in the render tree. If it's a comment, that will not be included in the render tree. Then we move on to layout. So generating the layout and preparing for what needs to be painted. And this will be dependent on the size of the screen so that all the elements have a width and height associated to it. And then lastly, painting. So actually painting the pixels on the screen. This is a visual representation of what the render tree looks like. So you can see here, this is containing all the elements that need to be painted, as well as the associated styles. So when optimizing, we want to prioritize the critical content that needs to go first. Now let's jump into some optimizations. So we will start with image optimizations and understanding a few techniques on how we would improve the performance for images on a particular page. One technique is prioritizing above the fold, which we mentioned, and that's basically what is visible to the user. So one thing that we can do is any image that is above the fold and termed critical, we can add the importance attribute to tag that this is of high importance. So load this image first. We can also add preloading so that we are asynchronously loading these images and then they're ready to be loaded as they're needed. The other thing we can do is we can match up the images to suit the device. And what I mean by that is that they're scaled for the device or they're responsive images. That way, we don't need to load inefficiently. We don't need to load a large image for a small device. The other things we can do is we can tell the browser the width and height of an image so that the browser doesn't have to calculate this. Another thing we can do is we can set the source set. So that's actually defining a set of images for particular image sizes, and it's optimized for a particular device. So images all have different formats, and picking the type of image is important. In this case, we could use a modern format called WebP, which has found to be 26% smaller than PNGs. And that's important if we want to start being smart about the images being loaded. Another technique we can use is lazy loading images. So basically loading an image when you're actually needing it and prioritizing the images that are viewable first. So you can see here that when you do that, you will then start freeing up the initial page load, and you don't need to load assets that you don't need to. So images that are off the screen don't need to be loaded. Now that I've covered image optimizations, let's dive into some things we can optimize in CSS. So going back to critical rendering path, we can also identify which CSS is critical. So in your browser, in Chrome, there's actually a performance tab that you can run against the page. And when you do that, you can also scroll down and see different assets being loaded. And in this case, for a CSS file, you can identify what's critical and non-critical, and then start breaking that apart. So for critical CSS, we can pull that out and add that into the style tags in the header. That way that's loaded as one of the first items on the page. And then for non-critical CSS, we can load this asynchronously using preload so that once it's ready to be used, it's already loaded. We can also look at the resources defined in CSS files and preloading critical assets. So anything like fonts and background images could be preloaded. And that way they're fetched before the CSS files are downloaded. Another thing we can do is defining an image set for a background image. And that way that's optimized for the particular device pixel ratio of that device. Another thing we can do is we can use media queries. So with media queries, we often use that to define different styles to apply for device types. We can also use that for background images. That way we can target optimized images for a device. So now that we've covered what we can do in images, what we could do with CSS, we can now dive into some optimizations for JavaScript. So in this example, you can see a waterfall view and the order that resources are loaded. And looking at the image, every red arrow signifies a synchronous load. Basically, the browser waits for the JavaScript to load before continuing on and executing in the browser. Now that is, because it's synchronous, that is actually blocking the rest of rendering. Demonstrating how that works here, you can see in the green bars where the browser is parsing HTML, and then in the gray bar when parsing has stopped. And in this case, it stopped because the browser is now downloading JavaScript in the purple bar and then executing that JavaScript in the red bar before continuing on with HTML parsing. So that's demonstrating how a script is loading synchronously. To cater for this, we can actually add asynchronous loading. So you can see here, when the browser is executing HTML and parsing that HTML, the JavaScript is being loaded asynchronously. And then finally, when that JavaScript has finally been loaded, then execution of that JavaScript file takes place. And then finally, once that's done, the browser will continue parsing HTML. Another technique you can use is also defer. So in this case, again, the JavaScript file is being downloaded asynchronously. However, the browser continues parsing HTML, and once that's done, the JavaScript file is executed. So you use this technique for less critical JavaScript, for example, anything that's below the fold. Another technique you can use is code splitting. So this is an example from Lighthouse where it's flagged that the JavaScript being loaded is taking 15 seconds, which is quite big. And the recommendation here is to split that JavaScript up. So by doing that, if you can split that up, you can then lazy load JavaScript chunks in demand, basically as you need them. So you can see here, these are some tools that you could use to break up your JavaScript bundles. That way, now that you've got more than one bundle, they can be loaded separately as needed. And as a part of that, you will reduce the code downloaded on the initial load, as well as only loading JavaScript as you need it. Other things you can do here, you can rely on resource hints. So that's actually giving hints on when to or how to fetch resources. So in this case, we're using DNS prefetch, which means that DNS lookups are happening in the background. So when it's time to request that resource, the DNS lookup has already been completed, which will reduce that time to download the resource. Another thing we can do is we can use the pre-connect attribute. And this then allows the browser to set up early connections before requesting the resource, and then again, saving time on downloading that resource. So there's actually a lot more you can do to optimize everything. I haven't covered everything. For example, fonts. There are different ways on how you could optimize fonts. So I recommend checking out this guide by Google, which is a great start to understanding front-end performance, as well as some optimizations that you can do. So thanks for watching today. I hope you can take something away and bring back some of those techniques and improve the performance of some of your pages.